Hello, everybody, and welcome to our topic of the day, which is reliability. We're going to be taking a look at reliability and validity as two parts to sort of the same overarching topic. Both reliability and validity take a look at how accurate and reliable our measurements are. So let's go ahead and start off with just conceptually what reliability is, all right? So I think this is a great place to start. When we're talking about reliability, what we're talking about is consistency, all right? If something is reliable, it is consistent, all right? So if we have a human person who weighs 150 pounds, if they step on one scale 3 times, if it's a reliable measure, it should come out consistently to 150 pounds each time we use the measure. Well, sometimes we have some issues with this, right? Maybe we have a scale that's not entirely reliable, right? Maybe sometimes it reads us 150, sometimes 160, sometimes 145. That's not a very reliable or consistent measure. So what is reliability? Well, reliability is consistency, and in our case, we're going to talk about items in a measure. Think like a survey, like the one you create in this class. So we're concerned with the consistency of items within a measure and consistency of a measure over time. We're going to use a lot of analogies with a target, right, for both reliability and for validity, which again is sort of the sister topic to this, which will be our next topic. So the idea here is with reliability or consistency when measuring psychological phenomena, we have to understand that questions can, at best, only partially capture the characteristics of the things which they refer to. So that's a little bit vague, but think about taking a survey, right? If you ask somebody, how happy are you on a scale of 1 to 10, that will get at some portion of how happy somebody is, but not entirely, right? That will only partially capture the characteristic that we are trying to measure. So consequently, the question of just how well a test or measure captures the essence of a concept needs to be asked, all right? When we create a survey or a measure or a scale, we want to be sure that it is consistently measuring what we're claiming it measures, all right? So reliability is consistency, all right? And we're going to talk about a few different ways in which consistency is important. So first, we're going to talk about internal consistency. So consistency or reliability inside of a measure. So this is asking how consistently all items in a scale measure the concept in question. So let's stick with something relatively straightforward. Let's see, what do we want to stick with? We go to depression a lot, we default to depression a lot, and why don't we talk about it here? All right, depression is important to measure from a diagnostic perspective. So we have measures. We have something like the Beck Depression Inventory. We've spent a fair amount of time talking about in this course. All questions on the Beck Depression Inventory are going to be about depression, right? Every question will be about depression in some form. So every item will ask a question about depression, but it won't be exactly the same, right? It wouldn't benefit us to ask the same question over and over. So what we're really trying to do is get to multiple dimensions of depression. So how we measure internal consistency is using statistics. So the idea is that if we have a set of items that are all meant to measure depression, they should not be identical, or we would remove them during item analysis, if we remember item analysis. But we want to make sure that our items are all leaning towards the same concept being measured. So we have two ways of doing this. We have what we called split half reliability, where we literally split a measure in half, be it we split by odd and even numbers, we split actually in the middle of how many questions we have, and we correlate. We run a basic correlation on the responses to each of the questions and see if there's a correlation across each half of our measure. We would expect a strong correlation. We also have Cronbach's alpha. Cronbach's alpha is another method of doing this. We're taking the split half reliability coefficients or correlations and averaging them. All right, so I have a bit of a visual here on how we would do this. All right, so split half. We would take the two halves of a given measure, right? So we have some student scores On the left here, we would take, we have the statistic over here, we'd get the correlation coefficient and take a look to see if they are correlated. In this case, they are related, right? Remember, correlations are interpreted from -1 to +1. So if we have a positive 0.66, as we do here, that would indicate a strong correlation or a strong relationship between your two halves of your measure. Inner item correlation, how we get Cronbach's alpha, is a little bit more complex, and we just learned about correlation matrices in a previous exercise. So what we have here is a correlation matrix. What's happening here is that they're taking any two questions on a measure and correlating them with each other. So remember, we have that diagonal on the matrix where we see perfect correlation. So if we correlate item 1 and item 1, we're going to have a perfect correlation. But if we take a look at the others, we see lots of strong correlations: 0.89, 0.91, 0.92, 0.93, 0.86. So these measures aren't identical, right? We're not wasting our time by re-asking these questions, but what we are getting from this is an indication that all of our questions are leaning toward the same topic. Remember that correlation is imperfect. We can't imply cause and effect, but we can get a general idea here of the strength of relationships between the types of questions that we're asking in a given measure. So I have here sort of something to help us organize our branches of reliability here. So we were just talking all about internal consistency, all right, looking at items within a measure. So we looked at inner item correlations, split half reliability, and Cronbach's alpha. Now we're going to switch into other types of reliability. So internal consistency is a large branch, but we have a few other types of reliability that we are concerned with. So first we'll talk about test-retest reliability. Test-retest reliability is a lot like how it sounds. You can test somebody once, then you can test them again, and you'll see how consistent their scoring was between each of your tests. We also do this using a correlation. We look at the correlation between scores from a sample of participants at one point in time. We compare their score with another point in time. So test-retest reliability is great, all right? This is a wonderful test, right? We can do test-retest reliability to do things like, say, look at personality. Personality is supposed to be somewhat reliable or consistent or enduring over time. So if we give somebody a personality test at one point in time and we test them a year later, we would expect to see a similar outcome. However, test-retest reliability can be affected by carryover, or what we might call a practice effect. Say if you're looking at memory in individuals and you give them a memory test, if you give them a memory test at time point 1 and another memory test at time point 2, the same test, they might be better at it the second time because they've seen it before. So we just need to be aware of practice effects when it comes to test-retest reliability. So I have a more flushed out example here of a personality test, all right? So personality is a really great example of this because personality is supposed to be enduring over time to a degree. We know that things like trauma can affect someone's personality. But for example, if you took a personality test today and you scored the highest on openness, and then you take it a month later and you score the highest on neuroticism, you might want to question the reliability of that measure, right? It might not be as reliable or consistent as you might think. All right, so we have another form of reliability. We have something called alternate forms reliability. This is also a bit like how it sounds, right? This is having two forms of the same test to make comparisons across. So when a group of people compare two similar versions of an instrument, a test may be affected by memory contamination if it's used as a retest instrument. So that's a little bit related to what we had just discussed. But what we're talking about here is two forms of a measure that are the same in terms of scoring, but different in terms of content. So if we take what we've learned about psychological testing, now what we're learning about reliability, and with the information we've come to with our surveys, creating our surveys, you might be thinking that this is pretty hard to do, and you're right. To create a standardized, normalized, reliable test on its own is difficult to do. Now to create two of them is very difficult to do, all right? It's very resource intensive, very analysis intensive to make sure that you have similarity, enough similarity across your two forms. But we do have some tests that have this option, right? We have an example here of a speech language test that has parallel forms so that you can test the same person with two different forms and hopefully compare their scores for, say, improvement, so that they're not looking at the same measure that they have already seen. All right, so we're also concerned with alternate forms reliability over time, all right, in terms of test-retest. We want our measures to be consistent over time, so we have a few different layers of reliability that we can be concerned with at any given point. All right, now we have another type of reliability that's interesting to consider. You've maybe heard of this type of reliability before, even if indirectly, but called inter-rater reliability, meaning we have multiple raters rating some phenomena. All right, so we compare ratings across judges to test for consistency. When we do another statistical test, a Cohen's kappa, to take a look at the extent of agreement across individuals, all right? So if we have two independent observers, two independent judges judging, rating the same phenomena, we should expect some consistency or reliability across the raters. However, we know that this is not always the case, all right? This is a format of inter-rater reliability that you might be familiar with. A website that won't be named, for it is not a psychometrically sound website, but ratings, right? You going on and rating a product, an experience, right? We have Google reviews, Yelp reviews, right? Everything is rated by multiple raters on the internet these days. And the idea is to come to a consensus. If there are reliable, consistent ratings for whatever it is that you're observing, you'll be more likely to trust it. And that's exactly how we work in psychology as well. If we can get everybody on board rating things in the same way, we can say that we have some consistency or reliability in our measures, right? So another example, all right, here's a psychology example. Here's some brains, all right, this is from a brain imaging software called FreeSurfer. What FreeSurfer does is it captures the gray and the white matter in the brain, all right? So if you look at this, of course, the brain is not gray and white, but when we image the brain using MRI techniques, it comes out looking this way, looking relatively gray and white. So we have this system that automatically captures that contrast. It automatically captures the darker pieces of the image of the brain and the lighter pieces of the image of the brain, so we can do things like look at brain volume, differences in brain volume between gray and white matter. So the software is great, all right? It saves us a lot of time from manually doing this, like our wonderful devoted researchers in the past had to do, but it's not perfect, all right? It doesn't always do a great job, and this can be due to a number of things. This can be due to movement in the scanner. If anyone's had an MRI, you're supposed to stay very, very still. So we have something like this, all right? We can take a look and rate these brains. These are two different brains, slices from two different brains. The brain on the left, if we take a look, it looks like it's captured fairly well. The lines look pretty sharp. It doesn't look like we're missing too much in terms of outlining the different types of brain matter. If we look at the brain on the right, specifically the bottom left, all right, the bottom left where we have the yellow and the purple, it's missing some parts of the brain. So where I'm going with all of this is that humans will have to go in and manually rate the quality of these brain images, right? So we might say rate this on a 1 through 10 scale. The brain on the left might be a 9, the brain on the right might be a 5, all right? But we would get two raters to rate it, and of course this is just one slice. We would look at lots of slices of the brain in 3 dimensions. But we would rate the quality of the capture of the brain. We would get some internal reliability, right, some consistency through the inter-rating of the reliability, or maybe come to an average reliability or quality score of a given brain. All right, so we have here Cohen's kappa. This is the statistical method in which we would assess our inter-rater reliability. This is also much like a correlation coefficient. The closer we are to 1 is almost perfect agreement. We have that interpretation on the bottom right here. So if we have, say, 3 judges and we combine their ratings, we can get an inter-rater reliability score, and we want that to be high, all right? We want that to be as high as possible, or as close to 1 as possible, or as close to unanimous agreement. This is how we can make sure that we are reliably measuring or defining these phenomena in a way that's consistent across people, right? Consistent across scientists. All right, so that was our other branch of reliability. Again, we have 2 sort of separate domains. We have internal consistency within a measure, measuring the same concept consistently. And then we have these other forms of reliability looking a little bit more across different phenomena, whether it's raters or forms. All right, so a last word on why is this important? All right, why is this so important? Well, we're always trying to reduce the error in our data, right? If you remember anything from our statistics course or our statistics review, we're always trying to reduce error in our data in different ways, reduce, say, sampling error. But we want to reduce error in other ways as well. When we measure a behavior or a phenomena, we have a true score, all right? This is sort of an abstract idea of what we're really trying to get at, right? There's some real measure somewhere of what we're measuring, be it depression, right? We want to know how depressed somebody is based on some criteria. But we're bound to have some measurement error. Maybe it's people not understanding the questions that you're asking. Maybe it's sampling error in our norm groups, all right? Remember norm groups. So we move ahead with this general idea, and in statistics we have to accept error. We have to be comfortable and cozy with error. So if we have a personality score for openness of 75, we'd expect, right, that if we gave the test monthly for a year, the scores would be about 75. But let's say we see a little variance between 72 and 78. All right, but if we had seen scores that were much different, a much wider range, we would see more measurement error. We would see less reliability in that measure if it's something that we expect to be consistent. And of course, we talked a little bit about an experimental design. We often look at things over the lifespan that we would not expect to be consistent. So the final message here is that all of these topics that we discuss are dependent on your research design or whatever research design you're investigating. Different types of reliability will be important, different types of variables will be important, but reliability is always something that we want to look for. We want to make sure that our findings are reliable. If somebody were to conduct your study again, that they would get consistent findings as well. All right, that wraps up our talk about reliability or consistency. So our next topic is all about validity, which is accuracy. So these 2 topics are really taken together. So I'll see you over on that lecture.